Hello everyone, welcome back to Artificial and Facts channel. And we are back with a new topic, and at this moment, we will discuss about estimation and confidence intervals in analysis of variance.
Methods of sampling. There are several methods of sampling. Simple random sampling is the most widely used method. With this type of sampling, each member of the population has the same chance of being selected to be a part of the sample. Other methods of sampling include systematic sampling, stratified sampling, and cluster sampling. We begin by studying point estimates. A point estimate is a single statistic used to estimate a population parameters. Question number 1. What are the methods of sampling in probability? Confidence intervals for a population mean. Confidence intervals is a range of value construct from sample data so that the population parameter is likely to occur with the range at the specified probability. The specified probability is called the level of confidence. For example, we estimate the mean yearly income for construction workers in the New York's area is $85,000. The range of this estimate may be start from $81,000 to $89,000. We can describe how confident we are that the population parameter is the interval by making a probability statement. We may say, for instance, that we are 50% sure that the mean yearly income of construction workers in the New York area is between $81,000 and $89,000. To calculate a confidence interval, we must consider of two situations. The following example illustrate point estimate of population means. Tourism is a major source of income for many Caribbean countries, such as Barbados. Suppose the Bureau of Tourism for Barbados wants an estimate of the mean amount spent by tourists visiting the country. It would not be feasible to contact each tourist. Therefore, 500 tourists are randomly selected as they depart the country and asked the detail about their spending while visiting the island. The mean amount spent by the sample of 500 tourists is an estimate of the unknown population parameter. That is, we let the sample mean serve as a point estimate of the population mean. The question number 2. What does a confidence interval help with the estimation of? To calculate a confidence interval, we must consider two situations. First, we use data to estimate and the population standard deviation. Second, we use sample data to estimate width and the population standard deviation is unknown. In this case, we substitute the sample standard deviation for the population standard deviation. There are important distinctions in the assumption between these two situations. We first consider the case where is population standard deviation known as a confidence interval is computed using two statistics, the sample mean and the standard deviation.
Recall that the sampling distribution of the sample mean is the distribution of all sample means, X of sample size and from a population. The population standard deviation is known. From the information in the central limit theorem, we know that the sampling distribution follows the normal probability distribution with a mean of and a standard deviation. Also recall that this value is called the standard error. The results of the central limit theorem allow us to make the following general confidence interval statements using C statistics. First, 95% of the sample means selected from a population will be within 1.96 standard errors of the population mean. Second, 99% of the sample means will lie within 2.58 standard errors of the population mean. These confidence interval statements provide examples of levels of confidence and are called a 95% confidence interval and a 99% confidence interval. The 95% and 99% are the levels of confidence and refer to the percentage of similarly construct intervals that would include the parameter being estimated in this case. Question number 3, how are confidence intervals used in real life? How to determine a 95% confidence interval? Next is the solution. Where is the symbol for the standard error of the mean? We use a Greek letter because it is a population value, and the subscript reminds us that it refers to a sampling distribution of the sample means. Population standard deviation unknown. We cannot use the Z distribution. However, there is a remedy. We use the sample standard deviation and replace the Z distribution with the T distribution. The T distribution is a continuous probability distribution with many similar characteristics to the Z distribution. William Gossett, an English brewmaster, was the first to study the T distribution. He was particularly concerned with the exact behavior of the distribution of the following statistics. A confidence interval for a proportion. Proportion is the fraction, ratio, or percent indicating the part of the sample or the population having a particular trait of interest. Here are the sample proportion rules. And to develop a confidence interval for a population proportion, we use this formula as shown in the video. Choosing an appropriate sample size. There are 3 suggestions for finding a value for the population standard deviation. First, conduct a pilot study. Second, use a comparable study. And third, use a range-based approach. And here is the sample size for estimating the population mean. Example, A student in public administration wants to determine the mean amount members of city councils in large cities earn per month as remuneration for being a council member. The error in estimating the mean is to be less than $100 with a 95% level of confidence. The student found a report by the Department of Labor that reported a standard deviation of $1,000. What is the required sample size? The maximum allowable error, E, is $100. The value of C for a 95% level of confidence is 1.96, and the value of the standard deviation is $1,000. Substituting these values into formula, 9 minus 5 gives the required sample size as shown in the video. And the result will be 384.16. The compute value of 384.16 is round up to 385. A sample of 385 is required to meet the specifications. If the student wants to increase the level of confidence, for example to 99%, this will require a large sample. The C value corresponding to the 99% level of confidence is 2.58. And here is the solution. And the result is X 665.64. And we'll move on to the question number 4. How can you improve the accuracy of a confidence interval estimation? Sample size to estimate a population proportion. To determine the sample size for a proportion, the same three variables need to be specified. First, the margin of error. Second, the desired level of confidence. And third, the variation or dispersion of the population being studied. Here are the formula for the binomial distribution, the margin of error. And here also the sample size for the population proportion. And we'll move on to another example. The study in the previous example also estimates the proportion of cities that have private refuse collectors. The student wants the margin of error to be within 0.10 of the population proportion. The desired level of confidence is 90%, and no estimate is available for the population proportion. What is the required sample size? The estimate of the population proportion is to be within 0.10. So E equals to 0.10. The desired level of confidence is 0.90, which corresponds to a C value of 1.65. Because no estimate of the population proportion is available, we use 0.50. The suggested number of observations is N equals to 5.1 minus 0.5 and 1.65 over 0.10 raised to 2, and the final result is 68.0625. And the student needs a random sample of 99 cities. And we'll move on to another question. Question number 5. How does sample size affect confidence interval?
The F distribution. The probability distribution used is the F distribution. It was named to honor Sir Ronald Fisher, one of the founders of modern-day statistics. What are the characteristics of the F distribution? Number one, there is a family of F distributions. A particular member of the family is determined by two parameters: the degrees of freedom in the numerator and the degrees of freedom in the denominator. Second, the F distribution is continuous. This means that it can assume an infinite number of values between 0 and positive infinity. Three, the F distribution cannot be negative. The smallest value F can assume is 0. Four, it is positively skewed. The long tail of the distribution is to the right-hand side. As the number of degrees of freedom increases in both the numerator and denominator, the distribution approaches a normal distribution. Number five, it is asymptotic. As the values of x increase, the F distribution approach the x-axis but never touch it. This is similar to the behavior of the normal probability distribution. Question number 6. Why is the F distribution important? The following examples will show the use of the test. Two bars shearing machines are said to produce steel bars of the same length. The bars, therefore, should have the same mean length. We want to ensure that in addition to having the same mean length, they also have similar variation. The mean rate of return on two types of common stock may be the same, but there may be more variation in the rate of return in one than the other. A sample of 10 technology and 10 utility stocks shows the same mean rate of return, but there is likely more variation in the technology stocks. A study by the marketing department for a large newspaper found that men and women spent about the same amount of time per day surfing the net. However, the same report indicated there was nearly twice as much variation in time spent per day among the men and the women. In this instant, the null hypothesis and the alternative hypothesis are the test statistic is defined as follows. Test statistic for comparing two variances, f equals to s squared 2 over 1 over s 2 over 2. Example, Lemmer's limousine service from the City Hall in Toledo, Ohio, to Metro Airport in Detroit. Sean Lammers, president of the company, is considering two routes. One is via US 25 and the other via I-75. He wants to study the times it takes to drive to the airport using each route and then compare the results. He collected the following sample data, which is reported in minutes. Using the 10 significance level, is there a difference in the driving times for the two routes? Solution: the mean driving times along the two routes are nearly the same. The mean time is 58.29 minutes for the US 25 route and 59.0 minutes along the I-75 route. However, in evaluating travel times, Mr. Lemmers is also concerned about the variation in the travel times. The first step is to compute the two sample variances. We'll use formula to compute the sample standard deviations. To obtain the sample variances, we square the standard deviations. The usual 5-step hypothesis testing procedure will be employed. Step 1. We begin by stating the null hypothesis and alternate hypothesis. The test is to tell because we are looking for a difference in the variation of the two routes. We are not trying to show that one route has more variation than the other. Step 2. We selected the 10 significance level. Step 3. The appropriate test statistic follows the F distribution. Step 4. The critical value is obtained from Appendix B4, portion of which is reproduced as Table 12.1, because we are conducting a two-tailed test. Step 5, the final step is to take the ratio of the two sample variances, determine the value of the test statistic, and make a decision regarding the null hypothesis. Note that formula refers to the sample variances, but we calculate the sample standard deviations. We need to square the standard deviation to determine the variances. Question number 7. What are null and alternative hypothesis statements about?
To use ANOVA, we assume the following. First, the population follow the normal distribution. Second, the population have equal standard deviation. The third, the population are independent. For example, treatment refers to how a plot of ground was treated with a particular type of fertilizer. The following illustration will clarify the term treatment and demonstrate an application of ANOVA. Example, Joyce Kuhlman manages a regional financial center. She wishes to compare the productivity as measured by the number of customers served among 3 employees. 4 days are randomly selected and the number of customers served by each employee is recorded. The results are solution. Is there a difference in the mean number of customers served? This chart illustrates how the populations would appear if there were a difference in the determined means. Note that the population follow the normal distribution and the variation in each population is the same. However, the means are not the same. Question number 8. What are limitations of ANOVA? each of these difference is square and this square sum. This term is called the total variation. Total variation is the sum of the square difference between each observation and the overall mean. In our example, the total variation is 1082 found by in brackets 55 minus 58 square plus in brackets 54 minus 58 square plus in brackets 48 minus 58 square. Next, break this total variation into two components, that which is due to the treatments and that which is random. To find these two components, determine the mean of each of the treatments. The first source of variation is due to the treatments. Treatment variation, the sum of the square difference between each treatment mean and the grand or overall mean. In the example, the variation due to the treatment is the sum of the square difference between the mean number of customers served by each employee and the overall mean. This term is 992. To calculate it, we first find the mean of each of the treatments. The mean for Wolf is 56 customers, found by in brackets 55 plus 54 plus 59 plus 56 per 4. The other means are 70 and 48 respectively. The sum of the squares due to the treatment is in brackets 56 minus 58 square plus in brackets 56 minus 58 square plus in brackets 58 minus 48 minus 58 square equals 4 in brackets 56 minus 58 square plus 4 in brackets 70 minus 58 plus 4 in brackets 48 minus 58 square equals 992. Question number 9. How do you find the total variation of a function? The other source of variation is referred to as the random component or the other component. Random variation is the sum of the square difference between each observation and its treatment mean. In the example, this term is the sum of the square difference between each value and the mean for that particular employee. The error variation is 90 in brackets 55 minus 56 square plus in brackets 54 minus 56 square plus in brackets 48 minus 48 square equals 90. We determine the test statistic, which is the ratio of the two estimates of the population variance from the following equation. Estimate of the population variance based on the difference among the sample means. Estimate of the population variance based on the variation within the sample. The last step is to take the ratio of these two estimates. F equals 992 per 2, 90 per 9 equals 49.6. Question number 10. What are some examples of random variation?
That's all from our presentation. Hope you guys can understand and thank you for watching.